Okay, so the first question of this test is to use an augmented matrix to solve the system, it says. Okay, so we're going to need to put our augmented matrix into our calculator. I'll just write it down first. You can see from this system, um, there's no z term, so its coefficient is 0. Okay, so I'm going to define that in the calculator. It's a 3 by 4. Last thing I'm going to do is I'm going to check and make sure I've entered this properly. Okay, that looks good. I'm going to get out, get back in. Then I'm going to go over to math and go up to RREF. Then I'm going to get back into the matrix menu and under names I'm going to choose A. Okay, so that's telling me when I get it into row reduced echelon form, so now if I go from a matrix to a system, then the first row tells me, so the first column is my coefficients for x, then my coefficients for y, and my coefficients for z. The first row tells me 1 times x plus 0 times y minus 1 times z is equal to 0. The second row tells me 0 times x plus 1 times y plus 1 times z equals 0. Now the last row tells me 0 times x plus 0 times y plus 0 times z equals 1. That is a false statement. And if you have a false statement, it means your system is inconsistent, and so there is no solution. And if there is no solution, type in each of the blanks. That's what the instructions said to do. So that's what I'm going to do. Okay. All right, now it's asking me to do the same thing. So again, I'm going to need to write the augmented matrix. Then I have negative 1 times z, 0 times y, negative 1 times x, 0 times y, 7 times z, and equals 5. Okay. And I need to get this one into row reduced echelon form. Okay. So let me get my calculator. And again, we're going to get back into the matrix menu, go over to the editor. Again, I have a 3 by 4. And now I'm going to put these entries in. And now before I do anything else, I'm just going to double check. That's looking good. Now I'm going to get out, going to get back in, scroll over to math, go up to RREF, get into the matrix menu, and under names, just press enter, close off the parenthesis, and this is what we get. Now I'm going to go from a matrix back to a system. So the first columns are my coefficients for x, second column coefficients for y, third column coefficients for z. The first row gives me the equation 1 times x plus 0 times y minus 7 times z is equal to -5. The second row of this matrix gives me the equation 0 times x plus 1 times y minus 3 times z is equal to 1. And the last row gives me 0 times x plus 0 times y plus 0 times z equals 0. Now, this is a true statement, but it's no help. All of the variables have been eliminated. When that happens, we have a dependent system, and there are infinitely many solutions. Now, when there are infinitely many solutions, you have to write the generator, the general solution. So instead of 3 letters, you have to write it with 1 letter, and you have to use the letter Z. So we already know you're going to keep the letter Z. So already I know in here I'm going to have the letter Z. Now, what goes in the other spaces? Well, what goes in the other spaces is determined, is determined by these formulas. Now, if I add 7z to both sides of that formula, then I have xy plus 4 times z equals 12. Okay, and I need to enter in that matrix, augmented matrix. I'm going to use my calculator once again. Get into the matrix menu, go over to the editor. Again, it's a 3 by 4. Okay, now I might want to go back there and just double check that. Okay, that looks good. So now I'm going to get back into the matrix menu, go over to math, scroll up to RREF, get back into the matrix menu, and under names, press enter, close out the parenthesis. Okay, and once again, it looks like we've got an infinite one. If you've got all zeros on the third row, then you have a dependent system and infinitely many solutions, and you must write the generator. Okay, so this tells me 0 equals 0, which is true, but no help, so there are infinitely many solutions. So the first row tells me 1 times x plus 0 times y plus 1 times z is equal to 3. And so that tells me that if I subtract z from both sides, x is equal to 3 minus z. So instead of x, y, z, I'm going to keep the z. And instead of x, I'm going to have 3 minus z. So I have to write this all just with one letter z, and that's all I'm using. And then my second equation tells me 0 times x plus 1 times y minus 3 times z is equal to 2. And so now if I add 3z to both sides of this, I'll get this. So instead of y, I'll have 2 plus 3z. Okay, and so I have my generator now. And so if z is equal to 0, I would have 3, 2, comma, 0, which should satisfy all three of those equations. That's one possibility. There are infinitely many solutions. Okay. All right, so let's keep going. We got one more, it looks like. Okay. So I'm going to have 4 times x minus 2 times y plus 0 times z, and 2. 5 times x minus 2y plus 1 times z equals 7. And 3 times x, 4 minus 1, and 3. And I want to get that into row reduced echelon form. Okay. All right, let me get the calculator up again, and let's get back into the matrix menu. And again, let's get a 3 by 4. And we have 4, negative 2, 0, 2, 5, 7, 3, 4, negative 1, 3. Now let me just check it. Okay, that looks good. So I'm going to get back into the matrix menu, go over to the math, go up until you get RREF, get back into the matrix menu, press enter, and then close out the parenthesis. So we're going to get this. Now I'm going to go from the matrix to a system of equations. So where the equal sign is where that line is drawn. So the first row tells me 1 times x plus 0 times y plus 0 times z equals 1. Okay, so x is equal to 1. And I'll go ahead and put that in here because my answer is going to be a point in 3-dimensional space. And then the second row tells me 0 times x plus 1 times y plus 0 times z equals 1. So y is equal to 1. And finally, my last row tells me 0 times x plus 0 times y plus 1 times z equals 4. So my answer is there's a unique intersection point in 3-dimensional space, and it has coordinates 1, 1, 4. And that's what we put into here. All right. Okay, let's continue. Graph the solution region. Well, first, let's get y by itself. Let's subtract 2x from both sides. That does not change the direction of the arrow, but then let's divide everything by negative 2. Dividing by a negative does change the direction of the arrow. And that's going to be negative 2 plus 4x, plus x, sorry. Okay, so that's going to give me So the first line, I want it to be on and under. And let's have a look at what that line looks like and the region that we'll get. Let's come here and let's put -2 plus x. And let's do a zoom 6. Okay, and we want that line and everything underneath. Oh, so I'm going to do that in red. We want the line and everything underneath. Okay, now let's do the other region in blue. To get y by itself there, we don't have to do much at all. We just have to subtract 5x from both sides. And subtracting does not change the arrow. So I want the blue line and everything underneath it. So I'm just going to quickly go here and define the blue line. Okay, so I'm going to draw the blue line solid and everything underneath it. And now our solution is going to be the overlap. In this case, the purple region. And you can see that the purple region is that one. And so my answer to this is going to be A. Okay. All right. Solve the systems of equations using substitution. Okay, let's see what we have here. Okay, so I'm going to substitute x squared plus 5 in for y in this second equation. So I'm going to have 2x, then I'm going to have minus y. And now instead of y, I'm going to have x squared plus 5. And you have to put it in parentheses because the minus sign has to apply to every term. So then I'm going to have 2x minus x squared minus 5 equals -20. Let's put the x squared term out the front. And let's add 20 to both sides. And now I want my leading term to be positive, so let's multiply everything by -1. And 0 times -1 is still 0. Now I can get this if I can factor it. Two numbers that multiply together to give you -15, but at the same time they add up to give you -2, -5 and +3. So my solutions are going to be x is 5 and x is equal to -3. That will make the whole thing 0. So now let's see what happens. I have those. Okay, so suppose x is equal to 5. And then suppose x is equal to -3. Now, I'm going to use that equation. So y is equal to 5 squared plus 5, which is 25 plus 5, which is 30. And so I do get an intersection point, 5, 30. And then here, if x is -3, this will become -3 all squared plus 5, which is positive 9, which is 14. And so I get a second intersection point, -3, comma 14. Okay. Okay. So here, this would give me -9. No, that would give me -6, and then -14 equals -20. I'm just checking these in the other equations. That would give me 10 minus 30 equals -20. Okay, so we have two intersection points. And if there is more than one intersection point, so it's important to read the instructions, give the one with the smallest x value first. Well, -3 is the smallest x value. So the first intersection point is -3, comma 14. And you can see the parentheses and the comma is supplied. And then the next one, intersection point, is 5, comma 30. And then there aren't any more. And it said if there are fewer than 4, which there are, enter capital N for each remaining entry that you don't use. Okay. Okay. All right, I'm done with that one. Okay, let's look at this one. Again, I would use substitution. So if I add y to both sides, you get x is equal to 1 plus y. And now if I substitute into the first equation, instead of x squared, I'm going to have 1 plus y squared. Then x squared plus y squared equals 61. Now, 1 plus y squared is not 1 squared plus y squared. It is 1 plus y times 1 plus y. So I'm going to have 1 plus y plus y plus y squared. Okay, then plus y squared again. Oh, that's plus y squared. Yeah, I don't know where that came from. Plus y squared again, plus is equal to 61. So I'm going to have 2y squared plus 2y. Plus 1 is equal to 61. Subtract 61 from both sides and you'll get minus 60. Divide every term by 2 because we can. Okay, so two numbers that multiply together to give you -30, but at the same time have to add up to +1. So that would be +6 and -5. So I have two results here. Y is -6 or Y is 5. Okay. All right, so now let's see what our x values are. And again, I'm going to use that. So x minus y equals 1. X minus -6 equals 1. X plus 6 equals 1. Subtract 6 from both sides. And x is equal to -5. Now you got to be really careful because with the point, the x coordinate comes first. So -5 comma -6 is an intersection point, not the other way around. Here, um, going to write the same thing. Just trying to get my stylus to work. X minus y equals 1. So I'm going to have x minus 5 equals 1. Add 5 to both sides, and x is equal to 6. So again, instead of x comma y, remember the x value comes first. So I'm going to have 6 comma 5. So I have 2 intersection points. And give the one with the smallest x value first. -5 is the smallest x value. So -5 comma -6. -5, -6, and then 6 comma 5. And then that's all. So we're going to have ends in everything else. Okay. All right, on to the next one. Okay. Graph. Given the graph, identify the system of equations. Okay. Well, I think we can all see that the intersection point here is -3 comma 1. What does that mean? It means that -3 comma 1 is on both lines. So if you plug in x equals -3 and y equals -1 into both equations, they're both true. So let's look at equation A. You have -2 times -3 minus 7 times 1. Well, that's +6 minus 7, and that would equal -1, but here it has 9. So that cannot be true. Look at equation B. You have -2, then times -3, plus 3 times +1 is equal to 6 plus 3 is equal to 9. Okay, the first one is true. But what about the second one? It has to be in both of them. So the second one, you'd get 4 times -3 plus 7 times 1. And that's -12 plus 7 equals -5. And that's what you have there. I don't have to look any further because this intersection point is on both lines in the graph, so it has to make both equations true. And so there will never be more than one correct answer, so my answer here is B. Just my stylus is not responding to me. Okay. Let me try and plug this back in for a sec. See how that's responding. Okay, it seems to be behaving itself. Okay, I'm going to enlarge this. Okay. Now, we should be able to see this horizontal line here It goes through 1, 2, 3, 4, 5, 6, 7, 8. So this horizontal line has the equation y equals 8. And we would want y equals 8 and everything underneath it. Oh, also this is confined to the first quadrant, so we have to have these in there. And then we would want x equals 8 and everything underneath it restricted to the first quadrant, which would give you this big long band, but this would be part of it. Now, this vertical line here has the equation x equals, now x equals 1, 2, 3, 4, 5, 6, 7. And you would want the vertical line and everything to the left. Okay. And then you just have this line here. And you would want this line here and everything above. Now, what is this line here? Well, I can see that the point 0, 2 and 2, 0 are on this line. So I could probably have enough to do it from there. The slope of this line is going to be the change in x divided by the change in y. And so that would be -1. So the slope is 1. And you can see that the y-intercept is 2. So y is equal to mx plus b. Y is equal to -1 times x plus b. Okay. And I want, so that's the equation of this line. I want this line and I want the region above it with all these other restrictions. Okay, so this is what I'm going to be looking for. Okay, so now let me get rid of these. I don't want any of that. Okay. Well, same old story. It was working great when I was recording, but now it's just acting all funky. Because I want to get these other ones. Okay, so let's see now. If I get out of here, come back here. All right, I'm nearly there. That's just not responding. Okay, now it's finally responding. Okay, so I want these ones. The first one does not have the x is less than or equal to 7 in it. So it's not going to be the first one. And the second one, okay, again, doesn't have that. This one does not have x is greater than or equal to 0, y is greater than or equal to 0. So it should be the last one. So x is greater than or equal to 0, y is greater than or equal to 0, x is less than or equal to -7, y is less than or equal to 8, x is less than or equal to 7, y is less than or equal to 8, and then, oh, okay, if I add x to both sides of this, it does not change the arrow. Okay, so it's going to be that last one there. Okay. All right, let's continue on with this one. First thing we need to do is identify the corner points. Okay. So this corner point here has coordinates 5, 8. Then this point here has coordinates 7, 11. Then the next corner point here has coordinates 12, 5. And then this corner point here has coordinates 8, 1. Okay. So let's see if it's going to let me write with this stylus. So here is my objective function. And I have to plug in each of these coordinates into it. So if x is 5 and y is 8, I'm going to have 10 minus 24 to give me that. Now, let's do 7, 11. Then according to this formula, I have 2 times 7 minus 3 times 11, which is 14 minus 33. So that'll be minus 15. Okay, I think 9 minus 4 is 5, yeah. Okay. And then I'm going to have 12 and 5 in there. So I'm going to have 24 minus 15. And 14 minus 5 is going to be 9. And then I'm going to have 8 and 1. So 2 times 8 minus 3 times 1. 16 minus 3, which is going to be 13. Now, of these 4, the maximum is 13. So the maximum value is 13. It says only give the maximum value and nothing else. So I'm going to do that. Again, it's just not responding. What a nightmare. Okay, let's have a look at this. Okay. I'm going to try and plug this back in, see if it's behaving. Probably not going to, but we shall see. Okay. Meaty sandwich uses 2 slices of bread and 5 slices of cheese. Okay. And a veggie sandwich uses 3 slices of bread and 4 slices of cheese. Okay. There are 107 slices of bread available. So as far as the bread is concerned, you have at most 107 slices of bread. And a meaty sandwich, which we'll call an M, uses 2 slices of bread. And a veggie sandwich, which we'll call V, uses 3 slices of bread. So for every meaty sandwich, you have to have 2 slices of bread. For every veggie sandwich, you have to have 3 slices of bread. So if M and V are the total numbers, okay, I need to plug this in. Maybe that's why it was acting up. Who knows? So if M is the total number of meaty sandwiches and V is the total number of veggie sandwiches, then 2 times M plus 3 times V, it can't go over 107. You only have 107 slices of bread available. Now, what about the cheese? Oh, okay, so this has got to be in our formulas. Also, you can't have a negative number of sandwiches. So your number of meaty sandwiches has to be at least 0. So does the number of veggie sandwiches. Okay, so that's in all of them. Okay, so that's taken care of in there. Okay, that one is correct. This one is not correct. That one is correct. This one is not correct. Okay. So we only have to do A and D. Okay, now we get to cheese. There are only 101 slices of cheese available. And a meaty sandwich uses 5 slices of cheese. And a veggie sandwich uses 4 slices of cheese. And so this is the second equation I need. So 5M plus 4V is less than or equal to 101. Okay, and that's the wrong. So the one I want is A. So we want capital A. Capital A, please. I think it'll count it right if you put in a lowercase a. Okay, now A is an 8 by 12 and B is a 13 by 8. And if M is equal to B times A, okay. So it has to be in the order that they come in. Sorry. So we're looking for B times A. So B is a 13 by 8 and A is an 8 by 12. Now, is B times A, does that exist? Is it defined? Well, the inside numbers are the same. So yes, it is defined, and it will be whatever the outside numbers are. So it'll be a 13 by 12. (13 by 12). Okay. We can't do that. A minus B. Well, A is a 3 by 3 and B is a 2 by 4, and you can only add or subtract matrices if they have the same dimensions. So this does not exist. It's not possible to do that. It should be okay if it's capital, but make sure. All right, compute the inverse. This is 100% graphing calculator problem. All right, so let's get into the matrix menu, go over to the editor, and now we have a 3 by 3. Now I'm going to get out. I'm going to get back in and actually look at it. Make sure I've done it correctly. Okay, now I'm going to get back into the matrix menu. Under names, I'm going to do A, and then I'm going to press the X inverse button. Okay, so I want negative 29,14,9 on the first row. Okay, this one. Then I want 10, negative 5, negative 3 on the second row. And then on the last row, I want negative 35, 17, and 11. Okay, so the answer is B. Okay. All right, we're quickly getting to the end here. All right, let's okay. So, what we have is I'm going to do this matrix multiplication. So that lives in the first row and first column. So I take the first row of this, multiply it by the first column of that. And what do you get? You're going to get 2 times x plus 3 times y plus 1 times z equals negative 5. And that should be your first formula in all of these. Okay, so far all of them have the correct first formula. All right, now where does this live? It lives row 2, column 1, so I'm going to take row 2 and multiply it by column 1, and I'll get an equation. 6 times x plus 3 times y plus 4 times z equals negative 1. And now I'm going to look at the second equation from all of my, all right, that fits, that fits, that fits, that fits. Now, where does this live? Row 3, column 1. Row 3 times column 1. I'm going to get 2 times x plus 0 times y, so I'm not going to write anything, minus 1 times z equals 2. Okay, this one is not correct. This one is not correct. This one is not correct. This one, the last one, D, has all 3 of them the same. So the answer is D. I'm going to come back here, and the answer is D. Okay. And finally, let's solve the matrix equation. Okay. Okay, so they want you to solve this. And you know what A is, you know what B is, and so you're meant to find X. So how do you get X on this equation? Well, if A and B were just numbers, you'd divide both sides by A, but you can't do that with the matrix. Matrix division is not defined. So I'm going to multiply this by A inverse, and you must multiply the left-hand side by A inverse. Now, as long as A is invertible, everything's great, because when you multiply a matrix by its inverse, it has the effect of acting like the number 1. So this is going to be what my matrix X is. So I'm going to have to define X and Y in my calculator. X and sorry, A and B in my calculator. So let me get in here. Turn it on. Let's clear that. Get into the matrix menu. Go over to the editor. A is going to be a 3 by 3. And I'm just going to get back in. Okay, that's looking good. Now get in and go to the editor and scroll down to B. And B is a 3 by 1. And we're going to have 2, -7, 1. And let's get back in. And under names, choose A, and then press the X inverse button, then times, get back in. And in name, scroll down to B, because this is what we want. X is what we want, and it's going to be A inverse times B, and then press enter. And so X is going to be equal to this matrix. Now, if they've typed the answer out on one line, you might see it like that. Okay. Let's see how they have it. Over here. So we want 8, -39, 24. It's that one here. Okay, so I think that's all done, and I can submit. So I had a typo here, it looks like, on question 2, that one there. So if I do that again, when I get that into RREF, we get that. So I can't remember what happened on that one, but okay. So the first one gives me 1 times x, do that in black, 1 times x plus 0 times y minus 7 times z equals -5. So I add 7z to both sides, plus 7z, and I think I might have written minus 7z. And here the second one was y minus 3z equals 1. Okay, so yeah, that should have been a -5 plus 7z, and I think I wrote minus 7z instead. Okay, so that was the only typo that I could think about. So this one showed us that we got 0 equals 0, so it's infinitely many solutions. And here I add 3z to both sides. So if there's infinitely many solutions, you have to write it with one letter, and that letter is z. And so I have -5 plus 7z and 1 plus 3z. So that should have been -5 plus 7z. Okay, I think I wrote a minus 7z, so it was a typo there. Okay, so I'm going to stop it there.